Good morning, everyone, and welcome to another Fusion Friday. My name is Brian Mcmaster-Carr.
My name is Alvarez.
And we're application engineers here at KETIV Technologies. We here at KETIV believe that knowledge should be shared, and that's why we have these Fusion Fridays, is so we can share it with the community.
Absolutely.
Right.
Yeah.
And for those of you who are new to our Fusion Fridays, it's a series of webinars that we have every other Friday on all the different Fusion 360 workspaces. And if you've missed any of those, you can find them on our YouTube channel if you type in KETIV Fusion Fridays. So today is going to be a good one for those machinists out there, because who here has machined off a bolt, a vise, part of their vise?
Yeah, some unexpected cuts, right?
Yeah,
that you guys aren't expecting.
Part of your part that you don't want to be machined off. Yeah, we're all guilty of that. So that's why it's really important to simulate your toolpaths before you actually go in and run it on your machine. And that's what Fusion can do for you in the CAM environment. It has a simulation tool to do that for you. And it's always a good practice to simulate it and then run it on your machine.
Post out to your machine,
to prevent the least amount of these human errors as possible. So Alex will be telling us a little bit more about that. If you guys have any questions or comments about maybe the next Fusion Friday, you guys want to see a particular topic, feel free to leave that in the go-to chat room down below in the window there. So without further ado, I'll go ahead and pass it off to Alex, and he'll tell us a bit about CAM.
Perfect. Thank you for that, Brian. All right. So like Brian mentioned, today we are going to be talking about modeling your fixtures, right? So for those of you that don't know or are relatively new to fixtures, fixtures are pretty handy, right? Especially if you're doing a high production run. You want to be able to just machine the part and quickly switch, the parts in and out. They can save you a lot of money, save you a lot of time. So that's what we're really going to be focusing on today. So with that, you're going to have to do some sort of an assembly, right? So a lot of people aren't familiar with top-down assembly. So we're going to talk a little bit about some best practices when it comes to top-down assembly. We're also going to be creating our fixture, right, as the title states. But we're going to be creating the fixture based off our reference geometry. In other words, the model or the bracket that we have to machine, create the fixture off of that reference geometry. We're also going to be importing Mcmaster-Carr components. Really neat tool, right? We're just going to briefly talk about that and how to go about that inside your assembly. And then finally, we're going to add some toolpaths and program our bracket. All right, so top-down modeling, completely different from what a lot of traditional CAD users are used to, right? So a lot of traditional CAD users are used to the bottom-up design modeling, where you create each part independently from each other, right? So multiple parts, you bring in, you create an assembly file, bring in all of those parts inside the assembly file, and then either mate or constrain them together to get your final assembly. While here in Fusion, it's a little bit different. It's called top-down modeling, right? So in essence, you have a parent file, and then all the parts in that assembly then are going to be referenced off of each other. It can get a little messy at times, right, if you don't know exactly the best approach. But take, for example, a customer that I was working with not too long ago. He was designing these pretty geometric desks, right? So they were made out of wood. The wood planes were at different angles. And he was just in the prototype phase, right? So whenever he would change the angle of a wood panel with the bottom-up design assembly, he would have to go back in each part individually and then make those changes. We introduced him to the top-down modeling assembly or design method. So every time he changed that angle, all the other wood panels would change accordingly as well, right? So once you do get the hang of it, it can be extremely useful and very ideal for designs that undergo a lot of changes. All right, so with that, let's go ahead and jump into Fusion then and see what we have going on. All right, so this is a bracket then that we're going to be focusing on. Notice that I already have the stock that I'm going to be starting off created, right? So if we take a look here on the left, we see that we have the component, right? The stock component. Again, you can always rename these components if you ever wanted to save it, right? So you can always right click and then save your component, right? And then save that into your project there. So for us though, we are going to be creating the fixture today. So we need to come up with a way then, a pretty creative way on how we're going to be holding this part. This is some pretty thick material, so we might not get away by just machining the outside profile, right? So we might have to remove some of this other material until we get to the bracket, right? So let's go ahead and start creating that. I'm going to first start off then by creating a pretty large rectangle, right? So let's go ahead and do that. So we do sketch, rectangle, 2-point rectangle, right? We want the rectangle to be over here on the bottom and just create the rectangle, right? So let's pause there for a minute. What's going on here? So I created that sketch, but where was that sketch created, right? So it was created under the bracket sketch, right? So why is this important? So if I ever need to change the fixture, or if I ever need to change the dimension of a fixture, I'm not going to know exactly where that sketch is going to be at, right? So why do that when I can just create a new component and then have everything organized, right? So if I ever do need to go back to the fixture and make those changes, then I can go ahead and select the component, activate it, and then make those changes, right? So again, this is going to be a little bit of a hybrid between top-down and bottom-up, right? So again, to create a new component, just right-click here on the top node, new component. Right, so we get the new component created. A lot of people don't understand why your model gets translucent like that. That's just indicating to you that you have a different component active, right? So notice this little bubble over here on the next to the component, and that's just indicating to you that that's the active component at the moment, right? So now let's go ahead and create the sketch once again. Again, if you guys aren't familiar with the toolbox here, the S key on your keyboard, definitely recommend you guys to get used to that. Just begin typing out rectangle, right? So we see 2-point rectangle appears there. Just click on that. All right, so once again, we do want the fixture to be on the bottom here. Just do an arbitrary rectangle. We're going to start dimensioning it here right now. All right, so let's go ahead and start the fixture, right? So let's assume then that we have the dimensions already for our aluminum plate, right? So it's going to be a 9-inch by 20-inch fixture, right? So again, these fixtures, it kind of pains me sometimes when I walk into a customer and I see their machine and they only have one vise set up, right? Take advantage of the work envelope that your machine offers. Create these large fixtures so that you don't just machine this part. Maybe you have another part coming up and create a fixture for it as well, right? So I understand that's not always the case for a lot of people, right? It's always some pretty unique parts. But if you can maybe switch some jobs around and have 2 different parts machining or running at the same time, definitely recommend you guys to play around with that. Okay, so here we have our part, right? So we're going to turn our origin on so that we can fully define that, right? So notice that we do need a fully defined sketch, right? We don't want this moving around once we actually create our toolpaths because that's going to cause a lot of errors there, right? So let's go ahead and fully define this. And so from here to here, we're going to have 3.125, right? And then from this center to this center, we're going to have 9 inches. Right, so this is what I was referring to in earlier when I was talking about creating your fixture off of reference geometry, right? So right now we're referencing the origin of our part, right? So that's essentially what reference geometry or creating the fixture off of reference geometry is indicating, right? So let's go ahead then and extrude that. Let's just say 1.5 inches for this case. Right, so here we have essentially the base feature of our fixture, right? So we can even double click on this right here, fixture, and go from there. All right, so now we have the base part, right? So now how are we going to hold this part? First things first, we are going to need something to locate this stock, right? So whenever we machined the first part, we want to be able to locate where we're going to position our stock once we are ready to machine the second part, right? Again, there's many different ways to do it. One thing that I would probably use in this case is maybe do some dowel pins here, right? So have the holes here, 2 holes, I would probably say 2 dowel pins, right? Position them in a way that you can just push your stock in, right? And always have or always find that reference point from your stock, right? So let's go ahead and do that. Let's do a circle. Again, we're still working on the fixture, right? It's still active. We're going to be working off the top of this. And what we want to do then is project these 2 edges, right? So we want the holes to be tangent to them. So again, just two arbitrary circles here. And let's expand the sketch palette a little bit here. All right, so we want to make these 2 circles equal to each other, right? So whenever one of them changes, the other one's going to change as well. Right? So apply an equal constraint. All right, so now we're going to have these be 2.5 from center there. And then 2.5 from this point here. All right, so notice that they're right now in the part right here, right? So let's add a couple more constraints. Right, so let's go ahead and, so notice also how it's sometimes a little tricky to select the component, right? So I can just hold left click, sketch curve, right? Select that, make them tangent. Notice how it does have to be on the other side of it. Right, so let's just drag this out. Turn a few of these things off first. Turn that body off and then just drag it out this way. All right, there we are. Okay, so let's make these 2 tangent. Right, so it does matter where the circle's at when you are creating that tangent constraint, right? Okay, so now let's add a diameter for it. So we're going to be using a 1/2-inch dowel pin, and we just want the dowel pin to go in there nice and smooth, right? We don't want to force the dowel pin in there. We don't want the dowel pin to be in there permanently, right? So nice little slip fit. Let's do 502. Right, so there's our dowel pins there. You can turn on the bodies, turn on the stock, and then just do an extrude cut. Okay, so there we are. Okay, right, so there's our first feature there, right? And then all that's going to do really is just going to be help us locate where we're going to be positioning our stock, right? So we got that covered. Now we need to figure out how we're going to hold the part down, right? So my thought process behind this is clamping the part down, right? So having down pressure or down force, and then just drilling out those holes, right? Not all the holes, maybe we can drill a couple holes, and then just bolt it down, right? So we can bolt down the bracket there and then machine the outside profile. So let's go ahead and do that. For that, I will need some sort of a fixture, right? Of a clamp to hold down. For that, let's go ahead and use then the cam samples project inside of Fusion 360. So again, everyone has access to this this project, right? If you guys aren't familiar with it, right, expand the work holding. In this case, I'm going to be using the Mighty Bytes. And notice all the different options here, right? So you do have locating pins, machinable fixtures, right? If you want to create some sort of a soft draw there. So different options or different clamps that you guys can select in order to create these fixtures. So in my case, I already do have a fixture or a clamp selected. So let's go ahead and open that up. All right, so it is going to be this one right here. Again, I can bring it in, insert it into the current design. In my case, though, I'm gonna just go ahead and create the location for where they're going to be positioned, right? So again, just somewhere around here. In my case, I am just going to be using 2 clamps just to hold it down. Right? We're just going to be doing drilling operations while it's clamped down. So let's go ahead and dimension this one. All right, so it is going to be a 1/4 inch 20 tap that we're going to be using, right? So you look at the tap and drill chart, gives you a drill of 0.203. And again, just use a equal constraint. This one is equal to this one right here, right? Once again, project. No, we don't want to project that actually. So let's just give it a dimension, right? So from here to this edge, 0.375. Okay, and then from this edge to this edge, 0.375. Okay. Now we might have to move that just a little bit, but we'll see right now. Okay, so then finalize this dimension here. 1.125. Right, so once again, notice that we are going to be fully defining that, right? So that's going to be the key point here, is also fully defining your sketches. And then ensuring that they're not going to be moving anywhere, right? Okay, so then we have these holes ready. Again, let's go ahead and extrude cut an arbitrary value, -0.5. Okay, so there's our holes now for the clamps. So now what we can do then is insert this design into the current design, right? So it's as easy as just right-clicking, insert into current design, and it brings in the part there, right? So at this point, we can just kind of position it somewhere into place, right? Flip it around, somewhere around there. Okay. And now a lot of people, right, would be like, well, where's my clamp at, right? It doesn't show up as a different component. And reason for that is because this is the active component right now, right? So we expand this right now, look at where the component's at. It's under the fixture, right? Which we don't want. And so let's go ahead and delete that. Make sure that you activate the parent component and insert it once again. Right, so now that we have the parent component active, or the parent file active, notice where it creates the clamp, right? So again, flip it around, and there we are, right? So let's go ahead and start applying some joints. I'm going to just change this dimension real quick, right? So again, activate the component, right? I know exactly where that sketch is going to be at because it's all under the component that I just created, right? The fixture component. So if I delete this dimension, delete that dimension, and then just project these 2 edges. It's going to be 3/8 from there and 3/8 from this edge here. All right, so now stop sketch. All right, and then again, activate the main component or the main parent file and start applying some of these joints here, right? So let's go ahead and apply this one there. Apply it to this circle here, right? Creates it there. You can make it rigid, or if you want to have it rotate around there, right, you can do that as well. We'll just leave it at revolute for now. And a lot of people then, what they would do then is just come over here and insert into current design, or a better way to do it is just move copy, right? So create copy, creates it over here in space somewhere, Let's see. And there's the other one there, right? So again, J for joint. We want the bottom edge here. And that's also another thing that we have on our YouTube channel, right? A lot of people still are a little confused with joints. And that's something that we've already covered. If you aren't familiar with joints, then go ahead and watch our YouTube channel. So now that I just moved that, I tried moving it. I don't know if you guys noticed that, but it moves into place, right? Or it moves around. So that's because it's still not grounded, right? We just created the component. We didn't really necessarily give it some sort of a joint or a constraint. So let's go ahead and do that right now. So our fixture plate is what's going to be essentially fixed in space, right? So let's go ahead and right click on the fixture and ground that component, right? So now if we try to move that, it's not going to go anywhere, right? So the only thing that should move are these clamps. And what we can do then is align these two, right? So click on that face, click on this face right here, right click, align components, right? That aligns into, you guys want to make sure that you ground the stock as well. Right, so rotate this around, click on this face, click on this face, align components, right? And then do the same thing over here. So click on this face, click on that face, and align them. All right, so we have our fixture pretty much done. The last thing I would probably say to do is just do the dowel pins. So again, just another component, create a new component. C for circle, capture position, right? And then we want to start the dowel pin somewhere way on the bottom, and then just project both of these circles, right? Using the reference geometry that we already created. C for circle. And these two are going to be, again, once again, equal to each other. And they're going to be half-inch dowel pins, right? So 0.5, E for extrude, and then just select both of these. They're typically around 1.5, 1.25, right, dowel pins. And then C for chamfer. And give them a quick chamfer there. Okay, so now if we activate the main parent file, right? So this is essentially what we have so far. So now finally, let's go ahead and just do a couple of these holes just to hold down the part inside, right? So again, the holes are going to be a part of the fixture. So let's go ahead and make sure that we activate the fixture first. And then project some of the holes that we want to machine out, right? Let me go ahead and close that out. Okay, so if we look at the bracket then, the hole that I would probably want to drill out was probably this one right here. Again, this one right here, or this one, and maybe even add another bolt somewhere around there, right? So the reason why we're doing this is so that we can drill through the fixture, tap it, and then add 1/4" 20 bolts that are going to hold down the part once we remove the clamps, right? So let's go ahead and do that. C for circle. D for diameter. Okay. So let's do actually 3, 6, 8. And so we're actually going to do these 7/16 tap. So C for circle. C for circle there. All right, so the reason why we projected that is just so that we can get the center point and we know exactly where all these holes are going to be at, right? So do the same thing for this one right there. Make them equal. All right, so now we can do, right? So notice that there's still blue. Make them equal to this one right there. There we go. All right, so now what we can do is extrude that, extrude this one right here, and extrude this. These can go all the way through, right? So I can drag the handle, or I can just do through all, right? And it cuts through that entire fixture there. Okay, so now let's go ahead and just add some threads, right? You can add the threads. These aren't necessarily crucial to the model. And that's one thing that a lot of people are asking also is, if you model the threads, once you go into the CAM environment, are they going to be modeled in there as well, right? So the answer is no. Unfortunately, the CAM environment doesn't pick up the threads that you have. So with that, let's go ahead and do 16.
And also to make sure, if you have tons of different threads in your model, if you leave them as unmodeled, it'll speed up the your software, because it doesn't have to calculate all these detailed threads in each particular hole, and especially if a bunch of holes, it'll slow that down. So just leave it as like a picture image of a thread instead.
Yeah, so you have the choice of actually doing it modeled or unmodeled. And again, the reason for that is, if you do it modeled, then it's not going to, it might sometimes lag it, right? Lag your computer, or sometimes if you hover over the thread, then it's probably gonna, just pick up that entire thread, and you guys will notice that as well, right? So let me just make sure that it's the correct one.
But of course, if you wanted to 3D print it, then yeah, you'd leave it as modeled. But other than that, you wouldn't need to.
Yeah. So now we have the threads in there. Again, they're just visual, right? They're not actually modeled in there. So now let's go ahead and insert then the Mcmaster-Carr component that's going to hold that down. So to do that, pretty easy. Insert Mcmaster-Carr component. All right, and we're going to be using a screw bolt, socket head screw. We can use this one right here. This one's fine. And then scroll down over here to the left, right? So we can use partially threaded, fully threaded. Let's go ahead and just use fully threaded, right? And then 7/16 by 14. Let's just say we just want that 1-inch socket head screw, right? So let's go ahead and select our part. Again, you have a couple options here, right? IGES, PDF, SolidWorks, step. We can use a step file and just hit save, and it automatically brings that component into your assembly, right? So once again, just position it somewhere into place. You don't necessarily have to get it exact the first time, and that's because we are going to be adding these joints to it, right? So capture position. We want the bottom of this face, right, the center of that circle, to go here. We can make that rigid. So now what we can do then is do a couple copies of these.
And keep in mind, in Mcmaster-Carr, there's a bunch of different screws and bolts and things like that that are modeled, but there are some here and there that aren't modeled. Maybe some of the more extravagant kind of models that they haven't just created a CAD file for it yet. So if you're looking for something and the CAD option to download is not there, it's probably because they didn't model it yet.
Yeah. So notice what I also did there as well is that the parent file wasn't active, right? So with these, it is going to create a body for them. It doesn't create essentially a different component, right? So let's go ahead and make sure that you have the parent file active. Right, select that once again, fully threaded, 1-inch. And use the step file there, save it. Okay, so let's go ahead and position it into place. Shape for joint, right? It's going to give you that joint command. We want the bottom of this face to go here, and then just flip it around. Gives you that connection there. And then move copy, create copy there. and then just drag it around, right? So then
you can also do a Control C, Control P, or Control V, sorry, to copy and paste that component as well as the move copy command. If you guys find hitting it on your keyboards easier than using the tool on, or right clicking and using the tool there.
Yeah, many different options to go about that, right? So we're almost done here with the fixture. Again, it does take some time to get it all together, right? And let's do these last two here.
Yeah, but it's totally worth it in the end if it prevents you from machining off a bolt or a part of your fixture.
And then do this last one here, right? Shape joint, and we want to go to the center of that. Okay, so here we have the finished component. Again, we can probably add something else over here, right? So if you guys did have another part, or maybe this bracket has another feature behind it, you can also definitely just do another fixture for the back of that as well.
And there's also suggested in the comment section that maybe a third dowel pin could possibly be an option.
Yeah, definitely. Yeah, so I mean, if you guys, if this wouldn't be enough for you to actually reference your stock or keep it straight, yeah, you can add another third dowel pin here. So let me go ahead and jump into the CAM workspace. So with this, again, we're gonna have two setups, right? One for the fixture, one for the bracket. It's gonna be relatively quickly here. So let's go ahead and turn off a couple of these things, right? So we going to be focusing on the fixture for now. So turning this off, and we can even turn off our main component, right? So let's go ahead and focus on the fixture. Again, the CAM environment, pretty straightforward, right? We're going to be working from left to right. So let's go ahead and create our setup. Notice that right off the bat, our work orientation is incorrect, right? So let's go ahead and change that to select Z-axis and X-axis. So what do we want as the Z-axis? We want this top face to be perpendicular to the Z-axis, and our X-axis that is going to run across the length of our fixture there. Okay. So then we can choose a box point. I believe it's a relative size box here. Our stock relative size box, right, with no additional stock. So it creates that rectangle with no additional stock on these sides, right? So that's going to work for me. Let's go ahead and continue here. All right, so first things first, we can probably add a few spot drills just to start off, right? So let's go ahead and do a drilling operation. Tool. Again, I don't have a spot drill in here, right? So let's go ahead and look for a spot drill. You can type it up over here at the top, spot. Let's say we want to use this 1/4 inch spot drill. There we are. And then we're going to be selecting some of these holes here, right? So let's go ahead and do that. But notice that we want to do a hole diameter range, right? So we can do from, let's say, smallest hole being, I guess, 0.1, largest hole being, I don't know, 1/2 inch. Right? Containment boundary somewhere in here. And the heights, right? So the whole top, let's see. So the whole top is going to be from the model top. And the bottom height is going to be from the model top as well, minus 0.1. Right, you just want to go in there 100 thousandths for that. Okay, so let's see if it picks that up. Okay. Let me just do select faces in this case then. All right. Select that, select some diameter. It automatically picks up all those holes there. All right, so now you want to make sure that it does go in the correct depth, right? So it does. It's not going to be plunging in through the fixture. So let's go ahead and then just continue the drilling operation here for a few of them. So let's go ahead and do the dowel pins first. We can do Fusion Friday. Use this 3/8 inch drill. Okay, and then that one goes all the way to the bottom there. All right, so then with this one, we can even do a chip breaking, right? So we want partial retract for every 90 thousandths. The drill bit is going to go in, come out, right? So that again is used for when you have holes that that don't have any chip evacuation. The chip breaking is going to help with those chips there, right? So that's going to help out there. Do the next drilling cycle, which is going to be these bottom holes there. So select 13/64 inch drill. Right. And you notice there, select these right here. Okay. And then the last 3 holes that we have there, right? So it's going to be a 7/64, so 0.368 drill bit. Right, so we can even create one. Right, so do this duplicate tool, and then just change the diameter there, right? So 0.368. Change that to 0.368 as well. Okay. So then the last drilling operation then is going to be this hole here, right? So notice that what I'm doing here as well is I'm duplicating the toolpath. So that's why the face is automatically selected, right? So you just want to make sure that you clear out these holes, select these holes here, and then you're off to go, right? So create that. Now the next setup then is going to include my bracket, right? So just to finish off, let's go ahead and create a new setup. Turn on the stock that we have used here, right? So then the stock is going to be from solid. It's going to be this rectangle here. Let's go ahead and change the model orientation once again. Right, so it's going to be this top z-axis there. And again, the x-axis is going to be running across the length there. One important step too is the model, right? So it has 2 bodies selected. Let's make sure we deselect that. And let's make sure that we have just the body or the bracket selected in this case, right? So hit OK. And there's our setup there, right? So we can go ahead and do then a 2D adaptive clearing just to clear out the outside over here. And the tool that we're going to be using is going to be a 1/4 inch flat end mill. So it's going to use that. All right, OK. All right, so then next tool path, right, we can drill these 1/2 inch holes. So drill, select, and then just create a 1/2 inch drill bit, right? So Control D, run a tool, and then just make that again a 1/2 inch drill bit there, right? So 0.5.
So if you guys miss any of these button clicks that Alex is going through, don't be panicked. You can always find this on our YouTube channel, and you can always pause the video and see what values he's putting in and where he's getting, how he's getting to these places.
Yeah. So let's see here, do the slot. So 0.38, right? So we can use a 1/4 inch drill bit in this case. Right? So again, drilling operation. Let's use again a 1/4 inch drill bit. So using the filters inside of Fusion 360, right? So 0.25, 1.25, and then using the diameter for that. Right? So notice that we have now all the 1/4 inch tools here, right? So we want a 1/4 inch drill, select that, and we just want to machine this hole here, right? Heights, hole bottom, selection to the bottom here. Might ask for a point at this case, right? Being that it's not a full hole. So let's just see what it says. Yeah, so let's go ahead and select that hole instead. So that's another thing, right? You don't have the option to just work with whole faces. You can also do the points that you generate off of those holes there, right? So let's see if we can do this one right here. Select this hole there. And our drill gets created there, right? So what that's going to allow then is just go in with the 1/4 inch, with the 1/4 inch end mill, and then finish that pocket out, right? So select this. Again, the ramping type is going to be a pre-drill. We can select the pre-drill position to be this hole there, right? So now let's say that we wanted to simulate this toolpath, right? So let's go ahead and simulate that, turn off a few of these sketches. Okay, so simulating this. Now again, the toolpath is, it's showing the entire toolpath, right? So we can actually just speed it up, shows, the entire part. So now we would probably, in this case, be ready to post out to the machine, right? So one thing that would help you guys out is if you actually turned on the bolts, right? So let's go ahead and turn that on, right? So that's why we modeled them. Let's go ahead and turn. So this is essentially how we would be holding it on in this case, right? Without this one right here. So simulate that. Right, so right there, the tool is going to hit the bolt, right? So again, that's because we don't have them set as fixtures, so that's why the red indications didn't show up, right? So if you just selected those on your setup, edit, fixture, and then just select these 3 bolts here, right? So now regenerate the toolpath, and if you simulate that, right, we're going to get these red indications, right? So tool collides with fixture, tools colliding with fixture, right? So again, that's why you guys want to make sure that you do generate this, right? So in this case, we would just have to go back in here to the toolpath. Hey, go ahead and change the retract height to maybe 0.65. Enter that, and then now it's fully clearing that bolt there, right? So that's essentially what I had for today, guys. Again, it was a pretty lengthy webinar, but it did show you guys exactly how to create the assembly, how to create components within the assembly, and then add joints or fixture or constraints to that assembly, right? So we also talked about how to import Mcmaster-Carr components. With those Mcmaster-Carr components, then you can save them into your project, use them for maybe templates down the line. And then we also talked about the benefits of modeling your fixture, right? So at this point, if you guys have any questions, you guys can.
Yeah, it looks like Robert asked, do you bring the machine to the part or bring the part to the machine? And I think he's referring to, in terms of the beginning, just like the workflow in general, is it a good idea to model the fixture in the same, I would say, assembly, or the same where your data is stored in as the original model, or is he's also asking do you, or is it better to bring in your model into a fixtures model?
Yeah, I think I understand your question. Yeah, so in this case, I did bring essentially the fixture to the part, right? Really, for you, it's going to be all preference. So if you expect that part to be changing a lot, then go ahead and create a new file right from scratch, and then start inserting those components into the design. What that's going to allow you to do then is keep the reference between both parts, and then if you do make a change to the part, then that's when you're going to see those updates as well. It's going to be a more streamlined, more streamlined workflow, right? If you do that. But again, if you don't expect any changes, then I would just say get the part and then start modeling your fixture again as separate components. Start modeling it from that part. Right? So.
Yeah, if you have any more questions about that, Robert, or anyone else, feel free to email us and contact us. Reach out to us. We'd love to talk about the workflows and maybe how you would set it up in your CAM environment as well.
Yeah.
So it doesn't look like we have any other questions in the comments. So thank you guys for watching. Tune in 2 weeks for our next Fusion Friday. Once again, send us any emails, reach out to us. We'd love to talk anything about Fusion 360 or any other Autodesk products with you.
Yeah, and also we do have an event coming up in May. So if you guys are interested in that, it's going to be at Urban Workspace. So if you guys are local, feel free to stop by. Right?
Yeah.
It's going to be on advanced manufacturing on both CAM and 3D printing.
Yep, and that's going to be in Costa Mesa. So it's going to be Southern California. So, all right. Thank you guys again for watching, and we'll see you next time.